Check. All right, let me give this the old check. There's like a 30-second delay. And we are all good. All right, so in the Discord channel, I had a couple of different suggestions. So I'm gonna show how to set up DSP mixing, like mixing between two sources, both kind of like raw DSP, and Juice has a mix DSP module, which is really convenient if you're using the other Juice modules. Another thing I had an idea is showing how to convert math to code with a distortion algorithm. And then I'll start on a parametric EQ and see if I can get a typical, like, you know, like Logic's channel EQ or, oh, let me restart since you asked. Okay, so I'm gonna show you how to do like a mix control in your DSP, like in raw DSP, or the Juice mix dry wet module. I'm gonna also show you how to convert math to code with a saturation algorithm. And then I'm gonna start, somebody had the idea of doing a parametric EQ and having like a FFT analyzer, and then having like the controls move lines on the analyzer, kind of like Logic's channel EQ or the what's it called, the Pro Q, stuff like that. So I made a project called Mix Demo, and I guess we're just gonna write, I guess we could do both at once. We could write out the distortion algorithm, and then we can add a mix and stuff. So I think, let's see how we're gonna start this. Okay, let's go here. I'm gonna show, oh, I gotta get everything set up anyway. So let's go to the audio processor. This is a brand new project, so at the moment it's not supporting parameter attachments or anything like that, so we gotta set all that up. First of all, yeah, okay, let's start. Okay, so we are going to need a value tree. So we need an audio processor. It was struggling to understand. Yeah, I use the Juice tutorial that's on the website, and I've set up an analyzer. I haven't figured out how to change the scaling of the what's it called? Like the bottom scaling of the frequency range. So like I think by default like 500 is in the middle, and I think it makes more sense to have like 1000 in the middle. And I tried a bunch of things to like shift it and never really worked properly, so it'd be good to visit that again. I also have no idea what the FIFO is. I forgot. I have to look at the code again. I think, isn't that the, you know what, I'm not even gonna say anything, it sounds stupid. So yeah, so let's do this. Audio processor value tree state. Yep, and just like always, call it tree state. We're also going to need to inherit from the same thing, but with the listener. listener. Okay. We need our value changed and stuff like that, and parameter layout. So I'm going to go into my code snippets here. What do we need first? Here's parameter layout. Oh, that's the C++ implementation, not the definition. Here's the definition. Just a parameter layout. And then we also need the parameter changed definition. So yeah, that. And then we need to implement them. And we also can't forget that we need to construct the tree state. So tree state, audio processor to connect to, which is this. I haven't used an undo manager ever, so I'm gonna put null pointer. And I always call this my caps lock sometimes doesn't actually. Great. Oh, my caps lock gets stuck. Is that what it is? I put O-rings on my keys so they're a little quieter. I bet the cap lock O-ring is a little too high or something. Parameters, and then we just call create layout, and that'll work. We need to implement those two methods, the create parameter layout and the parameter change. So luckily I have that in the snippet. The only difference is you need to put your actual class name here. Apparently I saved this snippet while I was working on the diode amplifier, and yeah, this isn't gonna equal anything, so we just need to put a string here. I'm just gonna put input for the ID, and then I'm gonna put input for the name, but with a capital I, because this name is what shows up in the DAW, and then this is the ID that you use like in the plugin. And I'm actually gonna change this. I like just doing P and then the name. P for parameter. Input. So that could be input or drive. Most of the time it's the same thing. And oh yeah, we have to do parameter changed. So this is called every time the parameter listener hears a change, and then we just have to add our listener. So in the constructor, we will add a listener. Let's see, input. And then we put this. And then in the destructor, we remove the listener so that there's no memory leak. And that should be it. Now we have one parameter in our plugin by default, and then we're going to do this little trick that I always use so that the UI builds itself while prototyping. We're going to say return new juice generic audio processor editor, and then we say pointer this just and I'm going to hit build, and I bet it's fine. No errors first time. Let's see. Nice. Look at that. We've got one slider called input. And the reason this is showing up by default without putting any code. So that's an interesting story. I got into DSP plugin development because, so I have a PhD in music. My whole education has been based on music performance. So like my bachelor's was music technology with like percussion performance at the same time. Then my master's was music theory and composition, and then I did a PhD in music. And in that program, we were learning Max MSP, which is kind of like high level DSP. And I got super into it. And then I think I got recommended a video by the audio programmer by YouTube. And I watched like his how to start audio plugin development, and that was like 2017. And yeah, I fell in love with it. I've been doing it ever since. And so throughout my PhD, I realized that I really like plugin development. So I was gonna try to get a job doing that, and yeah, now I do. And that is the long story. So I've been doing this about 5 years, and I think I'm finally getting somewhat good at it. But it was a long struggle. Luckily, the audio programmer put out videos, because without him, I probably wouldn't have been able to do this. So yeah, I taught myself programming and kind of DSP at the same time. Oh, cool. Where at? Okay, while I'm waiting for your answer, I'm gonna make another parameter called mix. Oh, NYU. Okay, cool. Is that gonna be Vice for the beginning stages? Are you just starting with Juice? Or let me ask this: or what is the focus of the degree? Like, is it like mixing, mastering, like sound work, or is it like DSP? All right, I'm putting in this mix parameter. So that we have something to do with the DSP. Okay, let's make sure that works. Cool. Mix is there, input is there. Mixing, mastering, DSP, 3D audio, cool. It's awesome that they're letting you concentrate on whatever you want for a master's degree. So what are you gonna focus on? DSP, like Juice stuff? I mean, DSP isn't necessarily Juice, but yeah, I mean, you have good job prospects if you do Juice and DSP. I mean, there's really no shortage of jobs for qualified audio programmers. So let me start some DSP, and I'll write down the math of a soft clipping algorithm that somebody in the channel. What's some job prospects? I mean, there's a lot of contracting work that you can do other than working for Ableton. I mean, there's a lot of audio companies. I mean, really any of them. I mean, you know, the bigger ones are gonna be asking for more experience than some of the smaller ones, and then you could probably get some contracting jobs too. The audio programmers Discord channel has a channel for contract work, and you can message through there. You'll have to read the rules about it in the server, but you can message through there and get some contracting gigs. And then, like me, once you've done enough contracting jobs, you'll gain some experience and you'll get hired by a bigger company with an actual like full-time position. It took me like almost 2 years to get the job I wanted after I graduated. I graduated right when COVID started, so that didn't help. But yeah, it took me about 2 years of, I was working at a computer store and then I was doing some audio contract stuff for about a year, and then I got a full-time job. So it can be challenging, especially if you don't have a computer science degree, but you'll find some work. You kind of have to put yourself out there too. Start a YouTube channel like me, because it kind of helps us when you're applying somewhere. If they're like, "Oh, I've seen him on YouTube." I mean, it makes a huge difference. Actually, that's my biggest piece of advice. I think is putting yourself out there. You gotta, make LinkedIn posts all the times, follow the right people, make a YouTube channel, put yourself out there. Because if not, when they come across your resume, you're just some person, Let me grab this code. I work for Music Tribe. Let's see. Let me grab the math that one of our members found. Let's see. Was it in coding? Was it in DSP? Or was it? Ah, here it is. Okay. Let me just copy and paste this into a comment. All right. Let me copy and paste this and see if that works. So I'm gonna go here, I'm gonna write some comments, or let me just paste it, and yep, that's, I guess, good enough. So we'll do that. And so let's talk about this after I set up a little DSP loop. So to actually do some DSP and affect the audio, we're gonna need to loop through the samples, right? If you've seen my videos, you've seen this before. We can do it a couple different ways. I like using an audio block. I guess I'll do it both ways. I'll do an audio block and then we'll do the buffer, just because I like using the audio block. So we can say juice DSP, audio block float, and we can give it a name. I'll usually just call it audio block. And then we need to pass it what data to refer to. So we'll pass it the buffer so that the audio block has the contents of the buffer. And now, I guess I'll move this up. Now we have an audio block with the info from the buffer, which is cool. And then we need to just loop through all of the stuff in the audio block. So we'll just say for. I'll just say let's loop through the channels and then loop through the samples. So we'll loop through each channel. Channel less than, we have this cool method called audioblock.getNum channels, and then we'll just do channel plus plus. So we're going to do another for loop to actually loop through the samples in each channel, because if you have two channels, then you're going to want to affect the samples in both of them. So let's do another let's call this one sample equal to 0. Sample is less than, you guessed it, audio block dot getNum samples this time, and then we'll just do sample plus plus. Cool. So now we're looping through the channels. So if we have more than one, it will loop through both of them, and then for each channel we'll loop through the samples. So we need to grab the data that's in the channels. So this is going to be auto data, and that's going to be equal to audio block dot get. I forgot what it is for audio block, because it's the method is called two different things for buffer and audio block. Let's see, is it array of right pointers? No, that must be for the oh, wait. I forgot what it is. Oh, let me pull up your producer real quick. Look at another project. Oh wait, I don't have to do that because I have a snippet of the block. So let me just do that. Yeah, it's just, yeah, get channel pointer. Okay. So get channel pointer. Where is it? What? There we go. And we will pass it channel. And now what we do is when we're affecting the audio, we are going to be, what's up, Blaze and Mr. Tummy? Oh, Blaze, I'm doing the mix control with DSP and then converting the math to code. And then I'm gonna start on a parametric EQ after. So this is the code that you posted in Discord, or the math, I should say. So anyway, so to actually affect the audio, what we're gonna do is actually replace the contents of the audio block with new data. So you would actually do this at the sample level. So we'll say data sample, and then you would say equal to, and then whatever you put after equal to, like whatever equation or whatever you do, is gonna replace the data in the output. So you're actually using the same variable for input and output. Like there's really no input and output the way we're doing it right here. So like if you say data sample is equal to data sample times 2, right now data sample is the input, so the data that's already in the buffer or the audio block, and then you are replacing what's in it with, you know, this. So we're just making the data twice as loud, right? So yeah, that's a quick little explanation of the audio block loop. So what are we doing here with this math? So usually what you'll see is you'll see something like either f of x is equal to something, or you'll see that y is equal to something, and usually x is going to be your input value. So for example, if we go to a graphing calculator, I don't have a bookmark. Desmos. So cool. So if we just take a simple clipping algorithm, so let's just say the most basic distortion, a tan distortion. So we would say basically, let's see what happens. It's actually been a while since I pulled up Desmos. So we're gonna say tan of x, and look, that's what tan of x looks like. And then let's give our input x, instead of just x, let's give it sine of x, so that it's a sine wave. And so that's what tan is doing to a sine wave. So if we were to implement this in code, all we would really say is the output is equal to the tan of the input. And we could also drive this by putting a parameter right here. So if we multiply our sine wave by something, so a, we add a slider. If we multiply it, it's getting more and more distorted. And you can see it's kind of wrapping and doing weird stuff. So that's an example. We could also do arctan. So that would be more of a soft clipper. So here's one. So you can see it still looks like a sine wave, but it's a little flattened kind of. So if we drive it harder, it'll get square and square until it's basically square. Oh, it's always running into the microphone. So that's just a little. Oh, good. I'm glad you got it working. I'm gonna show the raw DSP way and the juice, the dry wet module way. But yeah. So when you're converting math to code, usually x will be your input, and then you'll see f of x or y, and that will be your output. I mean, that's the way I usually do it, and it works out. So if we were gonna take this one, oh yeah, forgot. This one has an a variable, which I guess could mean different things. It could be drive, or it could be threshold. So we can actually just try it and see what happens. So usually, yeah, if you see less than or greater than or something like that, that's going to be a condition, right? So it's just going to be if statements. So let's do this. How should we do this? Let's assume A is a threshold. Yeah, let's do that. Okay. So I'm just going to make a variable called thresh. And I'm just going to set it to, I don't know, 0.5. So let's do this. Auto input is equal to data sample. That way it's just a little bit more readable. So we're gonna say if X, which is our input, is less than A, which is, I'm gonna assume thresh for right now, and just, we'll see how it sounds. Then we'll do data sample is equal to whatever's in here. So X, so basically no change, right? So input. Then let's do an else if for the other condition. Oh, that's weird. Don't know what that macro means. So the same thing, but less than. Or I should say input less than and then input greater than. All of this. So let's copy this and just fill it out. So we know we're going to take all the A's and we're going to replace it with thresh. We're going to take the X's and replace them with input. Right. Okay, let me spread this out so it's a little easier to read. So I'm gonna do this. Thresh. Okay. Let's see. Data sample is equal to. And now to raise it, to square it, we can use std pal. So where do we need to put this? This is happening. So this whole term right here is being raised. So what we do is std pal, and the first input is the number that you want to raise, and then the second is the degree you want to raise it to. So we'll put this, and then we'll do 2. And then now we can get rid of this. And I think, yep, that looks right. Okay, cool. And then else, or I guess not else actually, it's gonna be another if or else if. So if we put else, I think the condition wouldn't match what that mathematical expression is saying. So we'll say input is greater than 1. What does this say? Oh, it's just cool. So we're gonna replace A with thresh, right? And then another thing I want to do is, instead of dividing by 2, I'm going to multiply by 0.5, just because multiplication is faster. Usually, I mean, don't know. The compiler might, you know, convert all division to multiplication anyway, but there's no way of knowing. So I'm just going to write multiplication. Also, I'm going to make sure this is a double so that it doesn't get rounded or anything like that. Okay. So we've got, what's weird is this doesn't account for, let's see, A is less, or inputs less than thresh, inputs greater than thresh, input is greater than 1. Oh, you know what? One thing that we need to do also is, instead of greater than 1, I think this needs to be the absolute value of input, because our input is going from -1 to 1, right? So does that make sense? Input. Yeah, because I'm assuming that this also means that if um -1 is greater than 1, so -1 being the absolute, or I'm saying that backwards. How do I say this? I know our signal is between -1 and 1, so I'm just assuming that this equation should also mean that no matter what x is, if x is negative, we also want -1 to be greater than our signal ceiling. I guess we don't know if this is considering negative values or not, so if it's not, we have to do absolute. So let's do this. Let's see, doesn't really matter that it says in, because I'm going to pass in input and it should use the correct one. So in fact, we should probably use that for everything, because I have a feeling this is only considering positive values. It might not matter, but typically whenever you're doing any DSP and you're like, let's say you didn't have this math to base everything off of, if you were just writing a soft clipping algorithm and you wanted a threshold, you would put in the absolute value of your input, because you want the negative values to also be caught when they go above the threshold, and the only way to do that is to convert them to a positive number. So I'm just going to assume that we can use the same logic. Yeah, so this should work. We can, let's put our drive in here, and yeah, so let's put a drive variable. So I'm gonna say 1.0, so that nothing is happening by default. So we'll say this times drive. So by default, our input multiplied by 1 doesn't do anything, right? So let's go into parameter changed, because I already made a let's make this all positive. So I made an input variable parameter, audio parameter. So in parameter change, let's do drive is equal to this parameter, but we want to convert it to decibels, right? So juice decibels, decibels to gain. Yeah, so we want to convert from decibels to gain, because 0 to 24 is obviously going to be decibels, but gain is going to be, you know, from 0 to 1, and then from 1, you know, anything above that. So this is going to be tree state get raw parameter value, and this is going to be, what is it called, input, and then it's an atomic, so we'll say load. So now anytime we move the slider, drive is going to be set. So let's just put this in the prepare to play also, just so that it initializes correctly. And now when we move the slider, drive should be updated, so we should get some distortion. So I'm gonna build this, and we're gonna check it in plugin doctor first, just because if something weird happens, I don't want it to blow our ears out. So I just want to look at it and make sure that it looks somewhat normal. All right, that built successfully. let's load, what is it called? It should be called mix demo. Let's see. Detour DSP demos. Mix demo. Build. Yeah, it's there. Am I just looking at the wrong folder? Yeah, this is the wrong folder because there's some third-party stuff there. This should be this one. Nope, wrong one again. It's the user one. Library, audio, plugins, components. There it is. Please select a supported format. Shouldn't a Rosetta build work? Wait, does it have to be universal? I thought it had to be Rosetta for that to run. That's weird. Okay. What? Let's rebuild it. I'm pretty sure Plugin Doctor needs it to be a Rosetta build. I don't know, do any of you use Plugin Doctor? It's pretty convenient. It's pretty helpful. Making sure that your filters are actually at the right cutoff and width and stuff. And then you can use the oscilloscope, check out your distortion. You can also check the phase. I don't know. I don't know what his deal is. All right, so I'm gonna move it to the other library folder. See if that makes a difference. It didn't like the other library folder. Oh, look at that. That's really weird looking. That doesn't look like soft saturation. Does it? Seems a little unreasonable, but look. Actually, it actually might be right because look, it's limited itself. See, it's not going above 0.8. Usually if your distortion is clipping at a cap, that's usually a good thing, because it means that the algorithm is in fact made to be distortion. It just looks kind of funny. I mean, it looks very interesting. Let me run through the code real quick and make sure that we didn't make a mistake. So a plus, so what gets raised to that? I mean, that's right. Okay, whatever. Oh, let's do some negative values, actually. Yeah, I want to go back and just see if we quote unquote take away some distortion. See what it looks like. All right. Oh. Why did the range not update? I hit build, didn't I? Oh, okay. That was weird. All right, so oscilloscope, and we go down. Yeah, look. So this weird fold happens at negative something. If we, okay, so ignore this right here and just look at the large slopes. That to me looks correct, like a soft saturator. But this, something's not right about this. Something ain't right. So maybe I don't need to do the absolute value. Oh, wait, I think I know what it was. Oh, that's what it was. Cool. Okay. Yeah, that looks right to me. That looks like a soft saturator. Now, it's clipped on the positive end, but not the negative end, which is kind of strange. So we might want to put a hard clipper at the bottom. I mean, it doesn't matter. I mean, it doesn't have to clip. It's just gonna get loud. Yeah, let's put a hard clipper on the negative part. Let's do that. And then we'll say, now this if, else if, else if. I'm gonna put another else if, but I mean, it's kind of dumb. Probably want to lower the amount of if statements you use. Let's do else if input is less than -1. We could do just a super hard clipper. And I think that will work. Yeah, it didn't like the folder for some reason. When I moved it, it worked. Wait, is it clipping? It doesn't look like it. Less than -1. Hold on, let's move. this to like 0.8 since that's where the positive part seems to be clipped. That's gonna bother me. It's not catching it. Oh. Because, okay, so this else if is only gonna run if this is not true, right? So if we just do if, yeah, there we go. Okay. So now they're clipped at the same loudness pretty much. But one end is hard clipped and the other end is soft clipped. So maybe let's soft clip the negative end. So we can do like this. We could do we could just do ATAN. So STD ATAN of input. I think we also have to do 2 divided by pi. So let's just approximate it. So this is a common clipping algorithm, soft clipping algorithm that came out of Eric Tarr's book. So you've got 2 divided by pi times the ATAN of your signal. So that's a soft clipper. So that should round it off instead of hard clipping it. So let's see if that actually does it. Oh, weird. Yeah, interesting. Okay, so instead, we should probably just soft clip everything no matter what. So no matter what happens, the final output goes through this soft clipper. That should do what I wanted it to do, I think. Although the volume did come down. So this is some live DSP experimenting. This is kind of how you create something. If you don't know what to do, or you're like, oh, I don't know how to create a distortion effect, just start with math like I did with this. We found this, and then as you look at it, you're like, oh, well, it does this weird thing, so maybe I'll try to stop it or something. And that's how you build an effect. I think the 2 divided by pi was bringing our signal down too far, so it was no longer driving hard enough to get the original effect. I think we're still gonna have somewhat of the same issue. Oh, yeah. What's weird, I feel like this should work. What am I doing wrong with this? If input is less than, let's just do -1, or no, back to 0.8. 0.8. I don't know, did I have a typo or is this what I had? It's still kind of doing the same thing. It's like folding right at... Oh, I think what's happening is... Okay, so you see how once it gets to negative 0.8, this weird thing happens? I think the this ATAN is making a huge effect on those samples. So like if the sample is can we make this larger? Go down to 20. So if the sample, yeah, it's like squaring off, like it's catching at negative 0.8, but it's bringing it down in volume way too much. So like negative 0.68. Okay, now what if we do absolute? And this is just experimenting. This is not based on anything really. Interesting. Okay, cool. So we get our soft at the top and then nothing at the bottom. So I think we need to raise the volume of everything by a static amount. So I don't even know what a good number would be. Let's do, I don't know, let's do 5. We might need to do it on the output instead of the input. Okay. But it's not catching. Okay, so apparently the signal is so small. Okay. All right, so let's leave that. Right, yep. Let's see. I'm just gonna get rid of this. It's not working in this situation. So let's just hard clip it right there. Can I type in here? Okay, good. Okay, so this is what it looks like, which is cool. There's no, I mean, there's nothing wrong with that. It's cool. It's different on the positive part than on the negative part, which is cool. So it's soft clipped at the top and hard clipped at the bottom, which is kind of tube-like, but the soft shape of the tube is usually much different. So let's see what it sounds like. Doesn't look like it'll destroy our ears, so. And it looks like Logic scanned it, which is good. All right, so I'm gonna take this off. I'm gonna make sure the gain is down. Okay. And let's check out. Oh, mix demo. That's pretty cool. It does sound like soft saturation. It does sound more like saturation than a regular soft clipper. So So I don't know where you found that, Blaze, but it's pretty cool. All right, so let's do a mix. It's pretty easy in the raw DSP. So what we're gonna do is would be a good way to do this. Okay, let's do this. Okay, so I'm gonna make a local variable called output. And what I'm gonna do is, instead of setting the data at each statement, I'm just gonna set output, and then at the very end, pass that output to the data like this. So at the end, I'm just gonna say data, what's it called, sample, is equal to output, and let's make sure that it looks the same. And the reason I'm doing this is gonna help us with the mix logic. So let's make sure that all works the same. Looks like it probably does. Yep, so you can get in my way. Okay, good. So let's do the mix. Okay, it's pretty easy. We already have our parameters set up, right? And it's going 0 to 1. Let's make it 0 to 100 because that's usually what the user wants to see, right? 0 to 100, and then we'll scale it ourselves. Let's go into the processor, make another float. Mix. We'll set that equal to 0 since that's what it is by default. And we'll go into parameter changed, and we will say mix is equal to, we need to map it. So we can use JMap, which lets you mix, lets you map one range of numbers to another. So our source value is the mix parameter, mix, and the source min and max, which is 0 to 100, and we're changing it to 0 to 1. Cool. So let's put that in prepare to play so that it also initializes correctly. And then the actual mix part is pretty easy. So we want when the mix is 0, we want only the raw input. And when the mix is 100, we want only the distorted signal. So we can say 1 minus mix times our, what's our dry? It's just going to be data sample. Right? So when mix is at 0, 1 minus 0 is 1. So 1 times whatever is right here is going to be what you hear, which is our raw unaffected signal. And then we'll do kind of the opposite. So we'll add mix times output, which is our distortion. So when mix is at 1, output is multiplied by 1, but data sample is multiplied by 0. And when they're 0.5, data is multiplied by 0.5 and output is multiplied by 0.5, and they're mixed together. So that should give us our back and forth mix logic. So let's try that in logic. All right, cool. Let's try it out. Turn off the beat. Mix demo. Cool. All right. So mix is at 0 by default, so we shouldn't hear any distortion. We don't. Let's put it all the way. So mix is at 100. We hear it. If we turn the mix down, We can still hear the distortion, but it sounds like it's mixed with the original signal because it's right there's the original signal, and it's a little kind of what's the word I'm looking for? Not asymmetrical, but you know, we're getting the distortion with a mix only at 9, and I think that's just because the distortion is so heavy. So if we had a more, so this is distorted, but it's just kind of like saturated, just a little bit of overdrive. So that's better, right? The mix sounds more even and linear. It's just whenever the distortion is super crazy, you know, you hear it when the mix is only at 10% because the distortion is that much louder. In fact, what if I wonder if maybe instead of using data sample as dry, let's do input, because I was not using it because input is being multiplied by drive. So if your mix is all the way down, you're still going to hear drive times input, but maybe that's a good thing in this situation. Let's see. So logic. All right, so mix. Yeah, see, that doesn't work. That's not what a user would expect to hear. So I think this was the correct way in our situation. So cool. Mix output. All right. So the question is, can we improve this so that we're not having if statements? I mean, it's not a big deal. If this was the whole plugin and that's the only if statements, I mean, I don't think it's really a big deal. I've done a lot of testing with like setting up basic C++ programs and then doing loops and stuff and timing things, and some if statements in the DSP code in the process block really doesn't make a huge difference, but it is not the most efficient. But I mean, how can we do this? One way, I think if we do this is equal to input, we can get rid of this if statement. Right? Because then we're only going to change output to some kind of distortion algorithm if it's above threshold. And if it's not, this isn't going to run anyway. This doesn't need to be else because it's not actually checking the same thing. Let's build that and make sure it looks the same. It does look different. No, it doesn't. It's because of that else if. It shouldn't. This is what we had before, right? This is exactly what we had before. Wait, why does it look different now? It might be because we moved out the... So maybe this doesn't work the way I thought it would. Okay, so let's do this. The if statements are there already, so it doesn't really matter. Let's see if that looks the way it did before. Oh, I'm just realizing. Yeah. Okay, so also if input is equal to fresh output. Yeah, we're getting a different shape. And it's because we added this output, or we added this output and kind of changed the way we're doing the data sample data. And that's making our distortion shape different, which, I mean, it's still distortion, but so it's still kind of soft at the top and hard clipped at the bottom, but I don't know, is anybody screaming at me? Like, do you know exactly what's going on? You're like, oh, you forgot, you messed this up? I'm gonna go back to before we had the mix. Oh, I'm gonna redo that. And let's go down here. And okay, so that should be the way we had it before. I also noticed that there's another else if right here. Okay, so maybe that was it. Maybe it was that else if. So let's do, let's put it back. So 1 minus mix times output plus data sample, no input, right? No data sample. All right, let me do this and I'm gonna read that again. Let me check this and then I'll data equals fresh times 1. times 0.5 again on the negative value. Don't really understand. Let me see. Okay, there we go. Now it's good. I think it was that else if. So now, can I go back to the way it was and say input? Oh, we can't get rid of this if, because if we get rid of it, then if input is above fresh, it's going to equal input. So that's not actually, I think that's what it really was.